Section 4.3 is on right triangle trig. I'm sure you remember some of your right triangle trig from your previous courses, and Sohcahtoa might sound familiar, but that is only half of the 6 trig ratios. So on this side, you can see we have our Sohcahtoa set up for you. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. But then on this side, we have their reciprocal partner. So we have lined them up perfectly. So cosecant is the reciprocal of sine. That's why it says 1 over sine here. And that means it's hypotenuse over opposite, right? You flip it over. Reciprocal means flip it. Don't make it negative, just flip it. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. Cotangent is the reciprocal of tangent, so it's adjacent over opposite. So these are the 6 trig functions we're going to have to memorize. And remember, it all depends on where theta is. So in this picture, this is theta. Theta is your reference angle. Remember, the opposite, you draw an arrow all the way across your 90-degree triangle, and it points to the opposite. The hypotenuse is always opposite of the 90-degree angle, and the adjacent is the one left over, or it's right next to theta, but the hypotenuse is right next to theta also, right? So it's the leg touching theta. So these are our reciprocal trig functions. We're going to use them in a second. Complementary cofunctions. So in my picture, my triangle picture, I'm going to erase some of this. If that corner is theta, and we know the right corner is 90 degrees, then triangle sum tells us that we have, I'll call this x for now, right? We have x plus theta plus 90 has to equal 180. Well, if I'm solving that for x, I would subtract the 90. X plus theta equals 90. And then if I just want x alone, I'm going to subtract theta. Well, as an equation, that corner is 90 minus theta. And actually, that's more helpful than you think. So we're going to call this corner 90 minus theta. That's the complementary corner, right? 2 corners that add to be 90 are complements. And then we call them complementary cofunctions in trig. So the cofunctions are written down here. If you know sine of theta, you automatically know cosine of the other angle, cosine of 90 minus theta, right? If I look at my picture, sine of this angle, oops, I wanted to change colors. Sine of this angle is opposite over hypotenuse. Well, cosine of this angle, if I leave the words where they are, is opposite over hypotenuse. So they end up being the same. So all of these are complementary cofunctions. We've got secant is a complementary cofunction with cosecant. And we've got tangent is a complementary cofunction with cotangent. So I'm going to write a little thing on the side here. Sine is a cofunction with cosine. Tangent is a cofunction with cotangent. Secant is a cofunction with cosecant. Do you notice anything about all the partnerships? All the partnerships are just the other word with the co either added or dropped, right? Sine, cosine. Tangent, cotangent. Secant, cosecant. Those ones, if you use 90 minus theta for the other corner, end up matching up. They are complementary cofunctions. I actually wanted to talk about the 6 trig ratios too, now that I think about it. For me, memorizing the 6 trig functions, sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. Let's be real, the tangent and the cotangent ones are really easy, especially because they're the same for both complementary cofunctions and reciprocal trig. For the other ones, the way I memorize it, if you look at the first letter, each trig function and its reciprocal, only one of them is allowed to start with a C. So if you're looking at sine, its reciprocal must start with a c, so the only one left is cosecant. If you're looking at cosine, it already starts with a c, so its reciprocal trig function cannot start with a c, so the only one left is secant. These are just things I do to help me memorize who goes with who. Okay, we're going to put this into practice. Oh, there's an example in the corner, right? Using numbers. If I know sine of 32, if I do 90 minus 32, I get 58. So I also know cosine of 58. This is a really good multiple choice question. If I know tangent of 30, well, let's not use 30, 35, what else do you know? Well, tangent, complementary cofunction, cotangent of 90 minus 35, what is that, 55? Those are going to be the same. Okay, let's see what's next. Okay, our first example of trying to find all 6 trig functions. So first of all, we're not going to tell you what the 6 of them are, right? So you probably want to practice writing them down. And it's a good idea to write them down in partners. So we've got a theta in the corner. So I'm going to find sine theta, and then I like to put that right across from who goes with sine. Sine starts with s, so its reciprocal must start with c, cosecant theta. We always know cosine, maybe I'll leave another line, cosine theta. Cosine starts with the c, so its reciprocal can't. It must be partnered with secant theta. And then tangent, and tangent is always partnered with cotangent. Before we begin, we need to find the missing side. So I do not know, in this case, the hypotenuse x. So a little Pythagorean theorem. Hypotenuse squared is going to equal leg squared plus leg squared. This is a little bigger than we would expect you to be able to do without a calculator, but you might also recognize that as a Pythagorean triple. When you're done, x ends up equaling 17. So I'm going to replace this with a 17. Also, this should have had a 90-degree corner in it. That was just a typo. It should have already been printed on your notes for you. I apologize. Okay, so based on where theta is, probably a good idea to label things with O's, A's, and H's for opposite adjacent hypotenuse. So based on where theta is, way over here, 8 is the O. The slanted one, or the one across from the 90, is the H, and the other leg is the A. So see if you can do Sohcahtoa. See if you can, I'm just looking for a fraction, right? Each one of these is going to be a number over a number. You don't need a calculator. So see if you can do sine, cosine, tangent. Pause your video. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So now, because I wrote these down in partners, all I have to do is flip it over. Cosecant, 17 over 8. Secant, 17 over 15. Cotangent, 15 over 8. But let's try something else. What if the question also asked for sine of 90 minus theta? So just seeing 90 minus theta should tell you, oh, this is a complementary cofunction problem. The equivalent, the partner, who's the complementary cofunction of sine? This is the same thing as me asking. Remember, sine, you just add the co in front of it. So it's the same as asking me cosine of regular theta. And the cosine of regular theta is already answered up above, 15 over 17. Try another one. What is cotangent of 90 minus theta? So you see 90 minus theta, you need to remember, oh, it's a complementary cofunction. Who's the complementary cofunction of cotangent? So cotangent already has the co on it, so drop the co off, and it's the same question as tangent regular theta. Tangent regular theta is answered up above. Try one more. Secant of 90 minus theta. Who's the complementary cofunction of secant? And then what's the answer? So secant does not have co in front of it. So if I throw a co in front of it, I get cosecant regular theta. Cosecant regular theta is answered up above, 17 over 8. Okay, example 2. Not very often are we going to draw the triangle for you, right? So you need to be able to read the question carefully. Notice this says you're in quadrant 1 for now. That's because we will start doing things in other quadrants soon, maybe even tomorrow. But for now, you're drawing a right triangle in quadrant 1. Right triangles always touch the x-axis. Trying to make my right angle there. And they gave us some information. They told us sine is 5/6. But theta is always at 0, 0 between the hypotenuse and the x-axis. Theta is always at 0, 0 between the hypotenuse and the x-axis. So that means we need to label this with the sides. So we were giving sine, Sohcahtoa, that is O/H. So label your opposite side 5 and your hypotenuse 6. Based on where theta is, the opposite is over here, the hypotenuse is here. And then you need to do Pythagorean theorem to find the missing side. Remember, it's hypotenuse squared equals leg squared plus leg squared. If you don't put the hypotenuse in the right spot, you will get this wrong every time. So 36 minus the 25 and square root. So the missing side, and this is in quadrant 1, so it is positive to the right root 11, so positive root 11. Okay, see if you can get all 6 trig function questions lined up correctly. Set up your answer blanks so that they're lined up with their reciprocals. I always start with my Sohcahtoas, and then sine does not start with C, so its reciprocal does. Cosine does start with C, so its reciprocal doesn't. This is just a trick, by the way. It's not like mathematically sound. It's just how I remember who goes with who. Cotangent always goes with tangent. Okay, see how many you can fill in. Pause your video. When you unpause it, my answers are going to be there. Okay, well, my Sohcahtoa answers are there, so check those first. Then when you unpause it again, my other answers will be there as well. Okay, so sine opposite over hypotenuse, cosecant, I flipped it over. Cosine adjacent over hypotenuse, secant, I flipped it over. I guess I could have labeled them with you, but that's how we filled them in, right? The 5 is the opposite, the 6 is the hypotenuse, and the 11 is the adjacent. Let's try some more questions on the same picture. What is secant of 90 minus theta? While you're at it, what is cosine of 90 minus theta? See if you can figure out what those are asking. So as soon as I see 90 minus theta, I know they're talking about the other corner. They're talking about the complementary cofunction. So secant does not start with the word co, or the sound co. So I add co in front of it for the complementary cofunction. Secant becomes cosecant, just of theta, and my answer to cosecant was written up above. I see 90 minus theta, a complementary cofunction of cosine. Cosine already has a co in front of it. Drop the co and you're just left with sine. Sine was answered up above. Okay, example B. Remember, we're still in the first quadrant, but I'll tell you, as soon as I see reciprocal trig, I don't like reciprocal trig, right? I've been dealing with Sohcahtoa for, 3 years of my life? I'm talking as a student, right? I've been dealing with Sohcahtoa for 3 years, so I'm better at that. So let's change this to a Sohcahtoa question. If they give me secant theta, who's the reciprocal of secant? So secant starts with an S, its reciprocal means to start with a C, must be cosine. What would cosine theta be if secant theta is 3? Remember, this is over 1. Flip it over, cosine is 1/3. So you're going to draw a triangle in the first quadrant, a right triangle. It needs to touch the x-axis at 90 degrees. Then theta is always between the hypotenuse and the x-axis. I know cosine, ka, A/H. So the adjacent side must be 1, and the hypotenuse must be 3. Set up Pythagorean theorem and see if you can find x correctly. Pause your video. Remember, hypotenuse squared equals, again, you have no idea how many kids get this wrong because they put the hypotenuse on the wrong side. You should get root 8 for x. So let's change the x to a root 8. It is going up, so it makes sense that that's positive root 8. Let's set up our answer blanks. See if you can set them up. Sine, cosine, tangent. On test day, they might not be in this order, right? So I'm having you practice matching them up this way, but don't expect the answer blanks to be paired up on the test. Sine, cosecant. Cosine, secant. Tangent, always cotangent. Do your Sohcahtoas and then unpause your video. Okay, obviously cosine was given in the question, but still fill it in. And then reciprocals, flip them over. For tangent, you could put that over 1 if you wanted to. I chose not to. Flip them over for reciprocals. Same thing, you could put it 3 over 1 if you want to. And let's add another question. What is tangent of 90 minus theta? And then I'll fill in another one. What is sine of 90 minus theta? 90 minus theta, complementary cofunction. So you're always welcome if you don't like the trick. You could go to the other angle. See my purple star? Now I'm at the other angle. Tangent from that angle is 1 over root 8. So the answer is 1 over root 8. But I just think it's easier to know tangent complementary cofunction is cotangent. And you can see that I had already gotten that answer earlier for cotangent. So again, from the asterisk, sine from the asterisk, opposite of our hypotenuse, it's going to be 1/3. But that's because sine's complementary cofunction is cosine. Okay, example 3. So we're not always going to ask you for everything, right? So in this question, you're going to set up a triangle, and then I ask you 4 questions about it. So see if you can get your triangle set up. I'm going to pause my video. I'm going to set up my triangle. I'm going to label the 2 sides that are given, and then that'll be where I'm at when you unpause the video. Okay, does your picture match mine? Tangent of theta is 3 over 4. Pause your video now and see if you can find x correctly. Maybe you didn't even need to do Pythagorean theorem. That is a pretty common Pythagorean triple, 3 numbers that always make a right triangle that people tend to memorize. Now that you have your picture, see if you can find all the answers. When you unpause it, all my answers will be there. Okay, kind of ridiculous that tangent theta was the question blank there. Hopefully you got that one right since it was given in the question. I did a little work on the side for cosecant. I thought to myself, who's the reciprocal of cosecant? Oh, it's sine, so I did that off to the side. And then I got lucky that the complementary cofunction of cosine is also sine. So for the cosecant answer, I had to flip it over. But for the cosine answer, it was the same answer as sine. Okay, we are going to do a lot of word problems this chapter. So right triangle word problems or triangle word problems. So there's some important vocab we need to review. All of this vocab has to do with angles. So an angle of elevation. An angle of elevation is the angle above the horizontal line that the observer must look to see the object that is higher than the observer. When you elevate something, you are lifting it up. So it's usually from the ground or from the observer's angle, the observer's eyes, upwards. The angle from the horizon tilted up. An angle of depression, the angle below the horizontal line that the observer must look. When you are depressed, you are feeling down. So if you're in that hot air balloon and you're looking straight out, the angle of depression is from that horizontal line downwards. Coincidentally, these are equal, but if you put them in the wrong spots, you're going to get it wrong. Then some geometry, integrated 2 angle properties that you're going to need to remember this year. I'm looking for a color, sorry. Alternate interior angles. These kind of get offline in a second, but alternate interior, that is one example of alternate interior. C and F, they are congruent. In a picture, if you ever get that situation, you know they are congruent. Corresponding angles, an example of corresponding is A and E. They're on the left of the transversal. but they're both on the top of the parallel lines. Those are also equal, or congruent is a better word. And then vertical angles, one example of vertical angles just across from each other on an X, A and D, those are also congruent. So if you know one angle, you might also know a bunch of other angles depending on what your picture looks like. Okay, last one. Read the question. Notice I added B to the picture. For some reason B was missing there. So we do have a right triangle. We know an angle and one side. We want to know how wide the river is. So because that picture is kind of muddy with the colors, I'm just going to draw it again over here, right? I didn't even use shapes, but you get the idea. So we know this is 100. We know theta is 58. And we want to know W, how wide the river is. So this is just a regular Sohcahtoa problem. We have, or either as a number or a variable, we have opposite, or we're looking for opposite, and we have adjacent. Which trig function is opposite and adjacent? OA, tangent of 58, is equal to O over A. You put it over 1 and cross multiply. W is going to equal 100 tan 58. This would be the exact answer if it was multiple choice and that's where they stopped, or if I asked for the exact answer. Otherwise, you type it into a scientific calculator and you make sure you're in degree mode, right? I am typing in 58 degrees. I better be in degree mode. And you would get 160.033 feet. Always round to the third decimal place. There might be some worksheets and stuff that round smaller than that, like to the first decimal place. But anything you do for me that is freehand, I expect you to round to the third decimal place. Okay, that is section 4.3. I hope you guys are doing good.